Hello, Precalc. We are reviewing because you have a quiz coming up soon over 2-1 to 2-2. So I wanted to go through some things to remember as well as some examples to help you prepare. Things to remember. All right, so obviously the main focus over the last couple sections has been limits. Okay, so there's been all different kinds of limits. One possible limit, kind of the easiest one, is as x approaches some kind of a number, that means number, that doesn't make it undefined. All right, that doesn't make the function undefined. If you have something where x is approaching a number that doesn't make it undefined, all you have to do is just plug in x. All right, since it doesn't make it undefined, you can just plug it in, see what the number ends up equaling, and that's what it's approaching. The other ones are a little bit more tricky. All right, if it is as x approaches plus or minus infinity, what you're going to need to do is you're going to need to look at the end behavior or horizontal asymptotes. All right, the end behavior, remember we did stuff with end behavior model. So we're going to look at the end behavior / horizontal asymptotes. And I will do some examples to show you the differences. Let's say that you have as x approaches some kind of a vertical asymptote. All right, you know that it's undefined at that specific value. It's a vertical asymptote. This one, by the way, is as x approaches a vertical asymptote from the left or the right, not so it'll have like the plus sign or the minus sign. What you're going to do is we know that it will be either positive infinity or negative infinity. As you approach a vertical asymptote, it's got to either go up along the vertical asymptote or down along the vertical asymptote. So it will be either positive infinity or negative infinity. So what you need to figure out is which one it is. So if you recall, this is when we had to plug in a value that is close to the vertical asymptote. All right, so like if you're approaching 2 from the left, 2 is your vertical asymptote. If you're approaching 2 and 2 would make it undefined, you can plug in like 2.01 and see what it ends up equaling. And I'll do an example of that in a little bit. But that's what you're going to want to do is plug in a value that's close to the vertical asymptote and then see if it's positive or negative. And then you'll know whether it's positive infinity or negative infinity. The other possibility is as x approaches the x value of a whole. All right, so if you have something like that where x is approaching the x value of a whole, what you're going to do is you're going to find the y value of the whole. All right, I will do an example of that right now. All right, so how do you know it's a whole? How do you know it's a whole? All right, here's how you know. What's going to happen is, let's say that you have well, I guess I'm just going to answer this question. Let's say, how do you know it's a whole? What's going to happen is, let's say that you factor the numerator and you get something like x plus 2 times x plus 3. And let's say the denominator, you factor it, you get x plus 2 times x minus 5. If you notice, the x plus 2's are going to cancel. When these types of things cancel out, that means that there's going to be a whole. In this particular case, it'll be a whole at x equals negative 2. All right. The other possibility, if you can't factor it, it's not a very nice polynomial to factor. What you can do is if you plug in x into f of x, so you plug x into your function, and you get 0 over 0. That's how you know there's going to be a whole. All right, so I will do some examples so you can kind of see what I'm talking about. All right, so let's see. What's going to happen is, let's say that you have some examples here. let's say you have the limit as x approaches 3 of x squared plus 8x plus 15 all over x squared plus 7x plus 12. Okay. And let's say, actually, let's make this a -3. So what's going to happen is we have the limit as x approaches -3 of x squared plus 8x plus 15 all over x squared plus 7x plus 12. What I'm going to do is I'm going to factor the numerator and the denominator. And so I'm going to get x plus 5 times x plus 3. And I'm going to factor the bottom. I'm going to get x plus 4 times x plus 3. And if you notice, these are going to cancel out. All right. If you plug in -3 into the original function, you're going to get 0 over 0. It's a whole. You can also tell it's a whole because these two pieces cancel out and x is equal to -3, which makes those 0. So we know that it's going to be a whole at x equals -3, which is what we're approaching. So if we're approaching a whole, what we're going to do, we mentioned it up here, is if you're approaching the x value is a whole, you're going to find the y value of the whole. So what we're going to do is we're going to plug -3 into this function without those pieces that got canceled. So if you plug in -3, you're going to get -3 plus 5, which is 2, and then -3 plus 4 is 1. So you're going to end up with 2 for your answer. So because we're approaching a whole, we're going to figure out what the y value of that whole is, and that's what the limit will be equal to. Let's say you have something like the limit as x approaches 2 from the left side of 5x plus 6 all over x minus 2. All right, if you notice, we're approaching 2 from the left side. If you plug 2 into this function, you're going to get 0 in the denominator. You won't get 0 in the numerator, but you'll get 0 in the denominator, which means that x equals 2 is a vertical asymptote. All right, so we're approaching a vertical asymptote from the left side. Whenever you're approaching a vertical asymptote, the answer is either going to be positive infinity or negative infinity. It's just a matter of, are we going up along the vertical asymptote or down along the vertical asymptote? So what we're going to do is, because we're approaching it from the left, all right, what we're going to do is we're going to plug in a value that's close to 2, but on the left side of 2. So we're going to let x equal 1.99, just to the left of 2 on the number line would be 1.99. If you do that, 1.99 times 5 plus 6 is going to be some kind of positive number. Doesn't really matter what it is. 1.99 minus 2 will be a negative. You're going to get a negative answer, so that means it's going to be negative infinity. If you got a positive answer, your answer would be positive infinity. All right, let's see. Number 3. Let's say that you have the limit as x approaches infinity of the square root of 81x to the 4th plus x cubed all over 3x minus 4. Okay, so now the limit is approaching infinity. When we have a limit approaching infinity, we need to look at our end behavior or horizontal asymptotes. So we're going to look at our end behavior model, EBM, end behavior model. Remember, with our end behavior model, you take the highest degree in the numerator and the highest degree in the denominator. So really, we're just going to be looking at the limit as x approaches infinity of the square root of 81x to the 4th all over 3x. And we can simplify the numerator a little bit. This is going to be the same thing as the limit as x approaches infinity of 9x squared all over 3x. And then we can simplify this thing a little bit. We get 3x. All right, so we're going to be plugging infinity in for x. If you do 3 times infinity, that number is going to keep getting bigger and bigger and bigger and bigger. So my answer is going to be infinity. All right, so the answer would be infinity. It's approaching positive infinity. All right, the other way of thinking about it is if you graph 3x. All right, 3x is going to be linear. And when you graph it, it has a positive slope, so it rises from left to right. The end behavior as we go towards positive infinity, you can see that the end is going up and up and up. That's positive infinity. Let me see. Let's say that you have the limit as x approaches 6 of x plus 5. That's an example of one where you can just plug it in. It doesn't make it undefined. 6 plus 5, you're going to get 11. Nice and easy. If you have something like the limit as x approaches infinity of, let's say you have the cube root of 27x cubed plus 34x all over 4 plus 9x squared plus 10x. All right, so for something like this, again, it's approaching infinity. You're going to want to look at the end behavior model. The end behavior is going to deal with the highest degree in the numerator and the denominator. So really we're just dealing with the limit as x approaches infinity of the cube root of 27x cubed all over 9x squared. And so when you simplify that, you're going to end up with the cube root of 27, you get 3x all over 9x squared. So really we're doing the limit as x approaches infinity. If you reduce this, you get 1 over 3x. Well, 1 over 3x, you could graph that if you wanted to, or the other way to think about it is you're plugging in infinity. So you're really getting 1 over a really large number. And remember, if you have 1 divided by 9 versus 1 divided by 100 versus 1 divided by 1,000, as that bottom number gets bigger, the overall number gets closer and closer to 0. All right, so the answer is going to end up being 0. All right, the bottom gets very, very big very quickly, and it makes it go down to 0. The other thing to remember is that if the degree in the denominator is greater than the degree in the numerator, the horizontal asymptote is going to be y equals 0, and it's going to approach that horizontal asymptote as you go through. Let's see. Another one is the limit as x approaches infinity of 4x cubed plus 7 times 3x minus 6 all over 2x squared plus 5 times 8x squared plus 9. So for something like this, you could multiply all this craziness out. But again, we're focusing on the end behavior model. And so for the end behavior model, we're really just interested in the highest degree. So if we multiply the numerator out, the highest degree is going to be when you multiply these together, giving you 12x to the 4th. And then on the bottom, the highest degree is going to come from these two, which would be 16x to the 4th. And then we can simplify that. So again, we're just focusing on the end behavior model. We're going to end up with the limit as x approaches infinity of 12 over 16, or 3 over 4. All right, and there is no x to plug infinity in. It's just going to be 3/4. All right, you end up with a horizontal asymptote at 3/4. All right, so it's going to approach that horizontal asymptote of 3/4. Let's see. The last one will be the limit as x approaches 2 of x squared plus 5x minus 14 all over x squared minus 4. If you look at this one, it looks like 2 might be a vertical asymptote, but if you plug 2 into the numerator, you're going to get 0, which means that there is a hole at x equals 2. I think. Wait, let's see. 4 plus 10, 14. Yeah, so here's what we're going to do. We're going to factor this thing. You got the limit as x approaches 2 of, we're going to end up with x plus 7 times x minus 2. And on the bottom, you're going to have x plus 2 times x minus 2. So there's definitely a hole at 2. What we're going to do is just find out what the y value of that hole is. So if you plug in 2 into what's left, you're going to get 9 over 4. All right, so it's going to approach the y value of that hole. Something that will come in handy for you. Okay, so I paused the video so that I could write this down real quick. So voila, magic. Something that's going to come in handy for you is factoring the difference of 2 cubes. You're going to see this on the worksheet. So use this formula to kind of help you when you are factoring 2 cubes so that it makes it a lot shorter and easier for you to factor. All right, good luck with the worksheet.